Howdy, folks. I'm your host, Aphelion, host of the show Ephemeris Podcast, where we talk about everything relating to astronomy, from celestial objects to theories of the universe. Currently, we are in season 2, and we are in the Renaissance age, where we will begin to talk about the man himself, Nicholas Copernicus. And it's going to be a huge chronological jump in the series because we left off, if we forget about the bonus episode, we left off with um what was it? We did not leave off with Ptolemy, right? Who do we leave off with? Give me 1 second. I gotta remember. It's a little bit early in the morning, so I'm forgetting. It is Aristarchus that we left off with. Yeah. It was between Aristarchus and Ptolemy. So yeah, I apologize for that inconvenience. Anyways, uh, this time period, the Renaissance, will give birth to some revolutionary astronomy. And so we will start with the Polish astronomer Copernicus. And he was also a polymath. Copernicus developed his own heliocentric theory, as he's very famous for. And we're going to talk about it along with his book. I believe it's on the motion of the heavenly spheres, but there's a very complicated Latin name for it, which I've put down in my notes but don't really want to say. So we're just going to go with on the heavenly spheres, which is a lot easier to say. But something different about this episode, and probably going forward, is that we're going to have a substantial biography for astronomers now. So we get to talk about the character behind the work, not just the work. So, Nicolaus Copernicus, I believe his actual name was Nikolai Copernic, because his father was from the town Copernic. He was born in Torun, Prussia, which is modern-day Poland, on 19th February 1473, and he was the son of a merchant father and a mother who was related to a merchant, so merchant runs in the family. Copernicus had two sisters and a brother. He was the youngest, and his earliest documented education was in the University of Krakow. And he ended up being a pupil of an Aristotelian philosophy professor who taught him astronomy outside of the university. And this is kind of where he began to pick up astronomy. He started reading a lot of books, attending a lot of lectures, and he didn't stop at Krakow, I don't know why I said Krakow. I was thinking of like John Krakauer. I don't know. Anyways, he didn't stop at Krakow. Hopefully I'm saying that right. If I'm not, and you're Polish, definitely send me a strong comment in the comment section. So anyways, he didn't stop there. He also ended up in Bologna alongside the famous astronomer Domenico Maria Novara da Ferrara. And I would have loved to exercise my Italian accent there, but I really didn't want to. It's quite early in the morning. So here in the University of Bologna, he read about and critically thought about Ptolemy's work through, I think, some renditions that came through, what's his name? It was like John van Pierbach and Reggio Monantis. God, I forget the names. I should have put it in the notes. But anyways, so these two people, they're really famous in the Middle Ages for making a rendition of Ptolemy's work and kind of criticizing it. So he read that, and that was probably one of the more significant readings that he did. He also read about some of the Greeks that we've talked about in previous episodes, Aristarchus, Philolaus, Plato, etc. And once he was finished at university, he did for a while end up working with his uncle, because he ended up becoming like, his uncle ended up becoming like Archbishop of Warmia or something, and he had other plans for Copernicus to become a Catholic canon. So there's a whole confusing story that comes with that. I'm not going to get into much detail, but this is obviously not where Copernicus' journey ends, because we haven't even gotten to the good part. His theories would continue to be in the works even when he settled in Prussia, as he finished a framework for his ultimate piece in 1514. I forget what the name of it is off the top of my head, but um, from there, after his framework was done, he was already kind of progressing his whole heliocentric model on the heavenly spheres, and he worked on this piece that we talk about until the day he died. And close peers of his knew how amazing his work was, and it took a lot of convincing to get him to publish any of his work because there were several things that he was afraid of, which I think we'll talk about a little later on in the episode. A decent amount of his work didn't end up getting published before his death, but the authentic versions, I think some of his close peers wanted to get it out like the year he died, 1543, and sometime in the recent future during that time, but it only ended up coming out in the 18th century due to some weird complications. So, yeah, long story, but this is kind of nice to cover the character behind the work, as I said. So now it is time for us to figure out just how special Copernicus's work was. So let's talk about on the heavenly spheres. It obviously contained the heliocentric theory, but there are some other things that are important to mention. He had some theorems on chord geometry, and by chord I mean, like lines within a circle type of thing. There were descriptions of spherical geometry, which I think will be important when we get into the actual heliocentric theory. We've also seen it in other works. I don't remember if it was Aristotle or Plato, but I have a feeling it was one of those two that had to preface their big work with some spherical geometry. Then we have the precession of the equinoxes, which is something we've talked about in so many episodes, which I don't think needs too much elaboration. Apparent movements of objects like the sun, lunar orbits or movements, calculations on the position of stars in a heliocentric theory, and another slightly unique one, the digression in latitude from the ecliptic of the 5 planets. So, yeah, that one was definitely fresh to my ears. I haven't heard anything like that so far. And just to mention, these were calculations that were some decades in the making, and they were very meticulous, especially considering that there were no telescopes during that time. He still needed to rely on things like lunar eclipses, planets moving in the sky. So, yeah, I mean, you'll start to understand how revolutionary Copernicus's heliocentric theory was when you start to realize how much work went into it with how much or how little kind of advanced technology he had. So yeah, now that we're clear on everything else, let's investigate the uniqueness of the Copernican model. I hope I'm saying that right. Firstly, he stated that the universe consisted of 8 spheres, and the first thing I'll mention, or the first of the spheres, are the fixed stars. And that's interesting. He's kind of adopted that concept from geocentric theory, and I mean, I don't think there's necessarily an inclination to change that. It's justifiable considering that astronomers at the time had no reason to believe that stars were significant to their universe theory because you could barely see them, just specks in the sky. And I mean, obviously, if they had the ability to like observe something like redshift, they'd probably think something was going on with the stars as well. But yeah, I guess fixed stars for the most part seems justifiable even when you go from a geocentric to heliocentric theory. So that's the first sphere. Then you have 6 spheres for all 6 planets that are revolving around the sun. So obviously, for a long time, the only 5 planets that could be observed from Earth without a telescope would be Mercury, Venus, Mars, Jupiter, Saturn. And then you'd include Earth in that, and because you have a heliocentric theory, all of them would revolve around the sun. So that's 6 spheres. And then there's one left, and I don't think it'll come as a surprise that there was one sphere for the moon. and it had its own sphere for orbiting the Earth. So, in terms of solar structure, or solar system structure, pretty much spot on. There's absolutely nothing to complain about. Obviously, it's not the whole of the universe, but in terms of, if we're going to look at the solar system as we know today, everything about it, the way that Copernicus describes it, is spot on. And additionally, Copernicus justified the movement of the sun in the sky and stars with the daily axial rotation. I know daily axial rotation was something that came up with, I think it was even as recently as Aryabhat. But bringing it together in a heliocentric theory is an extra nice bonus. And it seems like the real model of the solar system and universe is coming together. But, and very unfortunately, there's a bone to pick, or even a couple, you might say. The first one is the fact that Copernicus was a believer of perfect circular motion. And you might say, well, what's the problem with circular motion anyways? I mean, it stood for quite a long time. We talked about it like many episodes ago. There's been no objection. The model seemed to be satisfactory with circular motion. Why is it a problem? Well, the problem with perfect circular motion is that the universe is not perfect. Theoretically, it's possible for planets to have circular motion, but this assumes that the planets have no initial velocity at all. Because planets do have some, not much, but some, initial velocity, it causes a dynamic between the sun and planets that is reflected best with elliptical orbits. Like the initial velocity, imagine the initial velocity as trying to make an escape from the gravitational force of the sun, right? Obviously, at some points, the kind of Earth is going to look like it's trying to get off of the trajectory of a completely circular orbit, but then the sun's going to kind of pull it in because it doesn't have enough velocity to escape. That kind of dynamic, if you can imagine it, would look more like an ellipse than circular. If the object had absolutely no initial velocity and kind of the centripetal force was the only thing that set it into motion, then yes, theoretically, it's possible that those orbits would be circular, but obviously the universe just doesn't work that way. Things come in with initial velocity, so it creates dynamics that are represented best by elliptical orbits. So just wanted to make that clear. I think if we make sense of that now, it's not going to be a problem when we get to later episodes. And so, yeah, when you switch from circular to elliptical orbits, that actually makes quite a huge difference when it comes to calculating, observing the apparent motions of planets. And this is the reason why, unfortunately, Copernicus had to apply epicycles to the planet's orbits in his theory to account for that, to kind of make up for that difference between assuming a circular orbit and an elliptical orbit. And thankfully, this problem will be fixed. I know I've talked about Kepler already many, many times. But for now, it's a reason to believe that there's still progress to be made with the heliocentric theory. You know, the story's not over. It's not happily ever after yet. Additionally, and this is kind of a very nice quote that I pulled from an article that kind of mentions the discrepancy with Copernicus' theory. So the quote goes like this. Copernicus was working with many observations that he had inherited from antiquity and whose trustworthiness he could not verify. Little side note, probably Ptolemy, but anyways. In constructing a theory for the precession of the equinoxes, for example, he was trying to build a model based upon very small long-term effects, and his theory for Mercury was left with serious incoherencies. So that's another bone to pick with the model. And the obvious one, I think I've talked about this already, is that the sun is the center of our solar system and not our universe. So that would be the problem with heliocentric theory in general, but also specifically with the Copernicus model. And yeah, that would be pretty much it for the work itself. There is quite a lot of backstory that goes into the reception of this work of Copernicus's. And as I talked about, getting Copernicus to publish the work itself was a process. He was hesitant to publish it for unclear reasons, but there were several possibilities. Like it could have been like just inconsistencies with his math, or fear of criticism from the public or the church. Like he had to consider things like, well, if I propose a heliocentric theory, how am I going to justify that heavy objects fall to Earth, or something like that, you know? So yeah, there are many possibilities why he was hesitant. We don't exactly know why. But the more he published his work, it seemed that people weren't exactly outraged about it. They're actually a little bit more curious, especially because, I mean, the people he sent it to, I think, were probably more intellectual than the general public. And he mentions that his work isn't really meant to be interpreted by the general public. So, yeah. But, anyways, bit of a tangent. He did. The reason why he did end up publishing the full On the Heavenly Spheres before his death was mainly because as he published fragments of his work, he realized that the backlash wasn't all that bad. And supposedly, and this is how kind of the story goes, kind of represented by this nice anecdote that I found. Under strong pressure from Rheticus, which is one of his close peers, and having seen the favorable first general reception of his work, Copernicus finally agreed to give On the Heavenly Spheres to his close friend Tiedemann Gaze, to be delivered to Rheticus for printing by the German printer Johannes Petrius at Nuremberg, Germany. While Rheticus initially supervised the printing, he had to leave Nuremberg before it was completed, and he handed over the task of supervising the rest of the printing to a Lutheran theologian, Andreas Osiander. Osiander added an unauthorized and unsigned preface, defending Copernicus's work against those who might be offended by its novel hypotheses. He argued that, quote, different hypotheses are sometimes offered for one and the same motion, and therefore the astronomer will take as his first choice that hypothesis which is easiest to grasp. According to Osiander, these hypotheses need not be true nor even probable. If they provide a calculus consistent with the observation, that alone is enough. And basically, what this whole story is trying to say is, firstly, Copernicus gave the responsibility of publishing it to Rheticus, but then he handed it over to some guy named Osiander, and he ended up adding his own little preface at the beginning of the book that just said, basically, I forget what the summarization of the quote is, but basically it's just this, while this theory might be a little goofy, there are reasons to consider it. Basically, I think that's basically the summary of the preface that was left by Osiander. And so this came to the dismay of Copernicus and Rheticus because they didn't authorize it and they didn't want their work to be seen that way. But there's a chance that it could have been kind of a saving grace, because obviously the church probably wouldn't have liked Copernicus being serious about a heliocentric theory, because there's a whole bunch of biblical stuff that talks about, why the earth should be at the center of the universe and all of that stuff. So yeah, that's pretty much how the story goes for the publishing. The reception, I know there was one guy, some pope, that ended up having some gnarly things to say about Copernicus's work after his death, such as like, I think he said that Copernicus was trying to completely flip the science of astronomy upside down or something like that. But yeah, that is pretty much it for Copernicus and his lovely piece on the heavenly spheres. If you enjoyed listening to this podcast episode about Copernicus and you are a new viewer who hasn't subscribed yet, which I notice is quite a lot of my viewing audience, I would genuinely appreciate a subscribe, and that is obviously if you're on YouTube. If you are on Spotify, thank you very much for listening on Spotify. I would appreciate a follow. And yeah, until next week, I will see y'all later. Peace.